How you doing, guys? Today I want to review some of the building collapses that I've done on YouTube and show you how a structural value engineer could review the design process. So today's all about building collapses, the structural review, and value engineering. Let's get started. As I stated in my previous value engineering video, I was involved with a construction management team to build a 25 million gallon per day, $25 million water treatment plant called the George R. Sweeney Water Treatment Plant. And we were obligated to bring in a professional value engineering team to review the overall design of the project. They were comprised of two value engineers. One was a structural value engineer and one was a plant processing pipe value engineer. Both of them were members of the Society of American Value Engineers, or SAVE. As I've stated in my previous value engineering video, value engineering is reviewing alternate materials, methods, and components in your design to maximize your overall functionality, value, and quality of your project. And as we did with this project, you could bring in a professional value engineering team to review your overall design of your project. Not only a value engineering team that looks at the architectural and the mechanical and electrical plumbing, but a structural value engineer to have another set of eyes to review the structural integrity of your building. So let's review the Hard Rock Hotel in New Orleans. It's a $70 million project, and it collapsed on October 12, 2019, in which 3 people died. And the east side of the structure sheared away from the main side of the building. And as I reviewed the structural drawings in my YouTube video, I noticed that there were only tie-back beams across the hallway at that shear area on 15 only. There were no tie-back beams from floors 8 through 14. Nor were there any tie-back beams on the 16th or 17th floor. And as you see here on this drawing, the pan decking on that east side of the building went north and south, where at the hallway it went east and west, and that's where the shear area happened. So in looking at the failed portion of the building on the east side, at the hallways, that's where it sheared off. The other item that I reviewed was the metal pan decking span distance between the columns and the beams. And as you notice on the 16th and 17th structural drawings, it shows a span of 28 feet. And all the other floors were 24 foot 9.5 inches. And I show a picture here of 24 foot 10 between those columns. Now, when in my research, the original drawings indicated that the pan decking was to be 16 gauge. And somewhere along the line, the contractor got approved and installed an 18 gauge metal pan decking. As I reviewed the pan decking span tables on their internet website, I came up with the same conclusion that OSHA did, that these distances were in excess of what they recommended on their tables. And with the pan deck distance being in excess and no tieback beams across those hallways, contributed to the collapse of the east side of the building. So as I stated in my other video, value engineering suggestion would be to add columns and beams, as you see here, on all the floors from floors 8 through 17, and then add the tieback beams across the hallways on each of these floors. Now, a structural value engineer, he's going to give you another set of eyes to look at your structural drawings and come up with value options, and have the construction manager oversee him so that they can put together a construction estimate to look at each one of these individual items so that you can all sit down together with the structural engineer of record, the owner, and the architect and determine what items you need to incorporate into the project. So let's look at the Champlain's Towers South building collapse that happened in Miami on June 24th, 2021, in which I reviewed this in a YouTube video on the factor of safety. And in my research on my YouTube video, I found that the planter boxes on the pool deck area were the culprit in the collapse of the east side of the building. As you see here on the pool deck here, and then a cross section. And what I found out was that there was the structural beams to be placed underneath those planter boxes to carry the weight, and then somewhere along the line, they revised the drawings to show no structural beams in that area. And what we found out, it was just a factor of safety of 1 for that support for those planter box beams. And the planter box beams tied into the east side of the building. And as we know, a safety factor of 1 in this area leaves no room for deficiencies during construction. A normal factor of safety for a building would be 2.5 or higher. And as we know, this precipitated the collapse of the building because it collapsed in this pool deck area. As we see here, it collapsed, and then the building collapsed. It was attached to that area. In reviewing the structural drawings on the east and west side, you'll see that there's just a small shear wall at the stairwell on the east side. There's not an elongated shear wall like there is on the west side at the elevator bank, nor are there any beams between the columns on the east side like there is on the west side. And we know the west side stayed intact. In my review, and what I would think a structural value engineer would look to do, was to add beams between the columns on each floor on the east side of the building, and also add a elongated shear wall on each floor. And then this gives it added shear and racking strength against the high winds, and if it's tied into that pool deck area. So let's review the Kansas City Hyatt Regency atrium walkway collapse that happened on July 17, 1981, in which 114 people were killed. Here are the 2 walkways that collapsed. You'll see the second floor and the 4th floor walkway on the left side of the picture here, and the 3rd floor walkway, which did not collapse, is right underneath me. And they're held up by 6 1.25-inch rods. And I've circled them here in red as you see them. They're 30 foot apart, and these walkways are 32 tons in weight apiece. And here's the structural drawings of the atrium walkways. And the walkways were to be supported by an I-beam across underneath, with the metal pan decking and concrete poured on top of that. And then they were supported by those rods on the right-hand side. And the rods would go through 2 8-inch C-channels, which were welded together. As you see down here, those 2 C-channels welded together, and the I rod would go through that. And then on the night of July 12th, 1981, when it happened, there was a tea party going on. And there was about 50 people on the 2nd floor atrium walkway and 10 people on the 4th floor walkway, and over 100 underneath the 2nd floor walkway when the collapse happened. And after the collapse of the atrium walkways, we find that there was no load calculations performed by the structural engineers of their original structural design. You can see where the 1.25-inch rod split through the 2 welded C-channels, and that was where the failure happened. So these examples give you an idea what a structural value engineer could do in reviewing your structural drawings, and they could be a part of a team of architectural and MEP value engineers reviewing the architectural and the mechanical and electrical of the project to see if there's any different materials, components, and methods that can be used to increase your functionality and your value and your quality of your project. And as I stated in one of my previous videos, John Roebling, who designed the Brooklyn Bridge in the 19th century, he had 7 civil engineering consultants review his design, and he had a factor of safety of 6 on his project. I thank you for watching, and I hope you have success on your next project.
Success. Success. Success.